Hi guys, welcome back to my channel. Before we start our math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. For this day, we're going to talk about arithmetic sequences and arithmetic series. This is the first type of sequence that we're going to talk about after our introduction about sequences and series in the previous video. Alright, so for your reference, most especially to my students, you can actually read more from page 21 until page 34 of your books. Okay, so first let us define if what is arithmetic sequence or arithmetic progression. It is a sequence whose succeeding terms are produced by constantly adding the same number. Okay, so it means that the operation involved here is addition. So to get the next term of the sequence, you have to add a number. Okay, so that number is what we call common difference. Common difference refers to the fixed number being added to the preceding term of an arithmetic sequence to get the next term in the sequence. It is denoted by the small letter d. So most of the references use d as the symbol for common difference. Teacher, how are we going to get the common difference? So you will now see in the coming examples if how are we going to do that. But this is the pattern. In getting the next term of an arithmetic sequence using the common difference, you have to add. But if you would like to solve for the common difference, the operation is subtraction. So you will subtract from right going to the left so that you will be able to solve for the common difference. Okay, so common difference plays an important role in writing the next terms of an arithmetic sequence. Next. Let's have now the formula for the nth term of an arithmetic sequence. So what do we mean by this one? If you are solving for the specific term, let's say for example, what is the 20th term or a sub 20 of the arithmetic sequence? So we will be using this formula. Okay? What if you are being asked to solve if what is a sub 100 or the 100th term of the arithmetic sequence? So this is the formula that we're going to use. So it is defined as the nth term a sub n of an arithmetic sequence with first term a sub n and common difference d is given by a sub n, which is the term, equals a sub 1, the first term, plus n, number of terms, minus 1 times d, which is the common difference. So again, the formula is a sub n, which is the term, equals a sub 1, the first term, plus n, the number of terms or the position of term, minus 1 times d. Okay, so that's the formula in finding for the nth term of an arithmetic sequence. It's also the what we call the general term of an arithmetic sequence. Now, let's have example 1. Write the formula for the nth term of the given arithmetic sequence. Letter A, we have 11, 25, 32, 39, and so on and so forth. So this one is an example of infinite arithmetic sequence since as you can see at the end we have the ellipsis symbol. It indicates that we have infinite number of terms in this specific sequence. So what's the question? The question is we have, or in the instruction, we have to write the formula. So in writing the formula, we will be using the general term of arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 times d. So this is now the formula that we're going to use. Now, how are we going to write the formula? In writing the formula, given the terms of the arithmetic sequence, you just need to identify if what is a sub 1. And a sub 1 is the first term of the sequence, which is 11. Then the next thing that we need to do is identify the common difference. So this is how you will solve for the common difference. You can choose any two numbers or terms, okay, and then subtract them from right going to the left. Just like in this case, we have 32 minus 39 minus 32. So 39 minus 32 is 7. So the common difference is 7. You can also try the other pairs Okay, so 32 minus 25 is also 7, 25 minus 18 is also 7, and 18 minus 11 is also 7. So therefore, we can now write the formula for this sequence. So just substitute a sub n equals the first term 11 plus, okay, n minus 1 times the common difference, which is 7. So the next thing is we have to simplify this and distribute the monomial to the binomial. Okay, so 7 times n and 7 times negative 1. Therefore, we have a sub n equals 11. 7 times n is 7n. And then 7 times negative 1 is negative 7. Then the next thing is we have similar terms that we need to combine. So in this case, we have 11 minus 7. So combine them. Therefore, we have a sub n equals 7n. 11 minus 7 is positive 4. So therefore, the formula for the sequence is a sub n equals 7n plus 4. This will serve now as your final answer. So if you would like to find the unknown terms or unknown term in the sequence, you can actually use the formula a sub n equals 7n plus 4. What is the general term that we use? We use the general term for arithmetic sequence. Okay, so let's have the next one. We have the sequence 9, 1, negative 7, negative 15, and negative 23. So how are we going to write now the formula? First thing is we need to have a sub 1. So a sub 1 is obviously the first term, which is 9. And then we need the common difference as well by subtracting. So negative 23 minus negative 5. So what is the answer? The answer is negative 8. Okay, so the answer is negative 8. Then the next thing that we can do now is to substitute the values. So therefore, we have a sub n equals a sub 1, which is 9, plus n minus 1 times the common difference, which is negative 8. Then the next thing is we will distribute the monomial to the binomial. Okay, so negative 8 times n and negative 8 times negative 1. So we have a sub n equals 9. Negative 8 times n is negative 8n. Then negative 8 times negative 1 is positive 8. Then we will combine the similar terms, 9 plus 8. So therefore, we have the general formula or the formula for the sequence a sub n equals negative 8n. We have to arrange it. 9 plus 8 is 17. So therefore, this is now the formula for the given sequence 9, 1, negative 7, negative 15, negative 23, and so on and so forth. So as simple as that. If the question is asking you to write the formula, that's the process that you have to follow. Okay? Next, number 2. Example number 2. Find the 15th term of the arithmetic sequence 16, 20, 24, 28, 32, and so on and so forth. In this specific example, we need to solve for the specific term. In this case, the question is we have to solve for the 15th term. We have to solve for the 15th term. So this is how you will solve it. We are looking for a sub 15. So before we can solve for a sub 15, we need the given values. So here we need a sub 1, which is the first term, 16. And then we need the common difference as well. 32 minus 28 is 4. And n is 15. Okay, so whatever is the unknown value, in this case a sub 15, therefore the number of terms that we're talking about is also 15. Then the next thing is substitute the values. A sub 15, which is the unknown term, equals a sub 1, 16. We are just following the formula. Plus n, 15 minus 1 times the common difference of 4. Then, class, we can actually use calculator in solving this directly. So in this case, we have 16 plus 15 minus 1 times 4. You can do that. Or if you would like to solve it manually, it goes like this. Just simply follow MDAS or PEMDAS rather. Okay, so 16 and then 15 minus 1 is 14 times 4. Then let us simplify. 14 times 4 is 56. So it's now 16 plus 56. So therefore, a sub 15, 16 plus 56 is 72. The 15th term of the sequence is 72. Okay, that's how you will solve it. First is you need to identify what is the unknown value, identify the values that you need or the given values, then use the formula, then afterwards simplify using some algebraic techniques or simple algebraic techniques. That's the time that you will be able to solve for the value of a sub 15. Now let's have number 3. Example 3. In the arithmetic sequence 6, 12, 18, 24, 30, which term is 120? So in this case, guys, we are looking if what is the position of 120 or the last term. Okay, because the question says which term. Which term? So it means that we are looking for the position of 120. Unlike the second example, as you can see, we are just looking for the 15th term. In this case, the term is given, but we are looking for n. Okay, so how are we going to solve for n? Of course, we have to identify the values that we need in the formula. Your a sub 1 is 6, and then your common difference, just simply subtract. So 30 minus 24 is 6. And then your a sub n is given, which is 120, but we do not know if what is the position of that term. Okay, so that's the problem that we're going to have or solve. We will be solving for the value of n. Then substitute the values. Your a sub n is already given 120. Your a sub 1 is 6 plus your n is unknown minus 1 times the common difference, which is 6. Then the next thing is we will distribute the monomial to the binomial. So 6 times n, 6 times negative 1. Okay, so 120, bring it down. And then 6 times n is 6n. Then 6 times negative 1 is negative 6. Then we will combine similar terms. 6 minus 6 is simply 0. So therefore, we have 120 equals 6n. Then to isolate n or solve for n, we have to divide both sides by 6. Okay, so therefore, n is 120 divided by 6 is 20. So the position of 120, it's the 20th term of the sequence 6, 12, 18, 24, 30, and so on and so forth. It's the 20th term of the sequence. So that's the process that we need to follow in solving for the unknown term. Okay, so you have to take note of this, guys. You are not only using the general term or the formula for arithmetic sequence in just simply solving for the unknown term or nth term. We can also solve it in solving for the value of n, value of d, value of a sub 1, and so on and so forth. Please make sure to follow simple algebraic techniques or rules in solving. Okay? Next, let's have example 4. Find the 18th term of the arithmetic sequence, which first term is 11 and which 7th term is 59. So in this specific case, we are looking for the term a sub 18 or 18th term. Okay, but as you can see, the terms are not given, or the sequence itself is not given, but the first term is given, which is 11, and the 7th term is given, which is 59. So these are the two values now that we can use in solving for a sub 18. But before we can solve for a sub 18, we have to do something first. We have to solve for the common difference. In solving for the common difference, we will be using a sub 1, which is 11, and a sub 7, which is 59. And n, of course, is 7, because as you can see, this is 7. So we will be solving first the common difference before we can solve for a sub 18. So we will now use the same formula. A sub n equals a sub 1 plus n minus 1 times d. And then substitute the values. Your a sub 7 is 59 equals your a sub 1, which is 11, plus your n, 7, minus 1 times d. The common difference is unknown. Then we will combine, or we will simplify this. So 7 minus 1 is 6. So 59 equals 11. 7 minus 1 is 6d. Then, okay, we will isolate 6d. By getting the opposite of 11, we call that addition property of equality. Bring down 59. Opposite of 11 is negative 11. Then 6d is equal to 48. So to get the common difference, we will divide both sides by 6. Okay, so 48, 6d divided by 6, then 48 divided by 6. Therefore, d is equal to 8. So our common difference now is 8. Then the next thing, since we already have the common difference, we can now solve for a sub 18. So using the following values, of course, a sub 1, which is 11, then your common difference, which is 8, and then since the unknown value is a sub 18, your n is 18. Then we will use the same formula, substitute a sub 18 equals a sub 1, which is 11, plus 18 minus 1 times the common difference, which is 8. Then let us simplify. Okay, you can now use your calculator in simplifying this, or maybe if you would like to solve it manually to be sure, it's up to you. So 18 minus 1 is 17. So 11 plus 17 times 8. Okay, then we will multiply 17 times 8. It's 136. So therefore, it's 11 plus 136. Okay, so to simplify, 11 plus 136, your a sub 18 is equal to 147. So this is now the 18th term of the sequence. So in this case, you have to learn on how to actually analyze the problem, use your critical thinking, and then do if what are the necessary things to do to solve for the unknown value. In this case, we solve first for d, and then after that, that's the time that we are able to solve for a sub 18. Okay, next, let's talk about arithmetic series. Of course, in our previous discussion, when we say series, it's the sum. So in this case, since we're talking about arithmetic series, sum of the first n terms of an arithmetic sequence is what we mean by that. Okay? So we have two formulas to use here. Okay, so given an arithmetic sequence where a sub 1 is the first term and a sub n is the nth term or the last term, the sum of the first n terms is given by, okay, let's differentiate the two formulas. In the first formula, if you're given is a sub 1 and your given is a sub n or the last term, you can use the simple formula s sub n equals n over 2 times a sub 1 plus a sub n. So we can only use this formula if the first term and the last term are given. How about the other formula, teacher? In the other formula, if your last term a sub n is unknown and you only have a sub 1, that's the time that you will use this. Okay? So s sub n is equal to n over 2 quantity 2a sub 1 plus quantity n minus 1 times d. Alright? So know the difference between the two. Again, if the first and last terms are given, you will be using the first formula. But if the last term is not given and you only have a sub 1, you can use the second formula. That's it. Now, let's have the following examples. Example 5. Find s sub 10 if a sub 1 is equal to 5 and a sub 10 is equal to 68. So, as you can see, our first term is given and our last term is given since we're looking only for s sub 10. In this case, we can use the simple formula s sub n equals n over 2 times a sub 1 plus a sub n. Then we need the following values, of course, to substitute. So s sub n is s sub 10 equals n, the number of terms, since we are looking for s sub 10, therefore n is 10. So 10 over 2 times your a sub 1, which is 5, plus your a sub 10, which is 68. Then, of course, let us simplify. S sub 10 equals 10 over 2 is 5. Then 5 plus 68 is, okay, so you have to add 5 plus 68 is 73. Then for the final thing, just multiply the 2, 5 times 73. So the sum of the 10 terms now, or the sum of the 10 terms in the sequence now is 365. Okay, so if we have the first and last terms, just simply use the first formula. How about in the sixth example, or example 6? Find the sub 25 of the arithmetic sequence 18, 23, 28, 33, 38, and so on and so forth. How are we going to solve now for the sum? As you can see, we have the sequence, which is the given. We can actually use here, what we can actually use here is the first term. And as you can see, the last term is not given, or a sub 25. So in solving for this, we have to use the second formula, which is s sub n equals n over 2 quantity 2 a sub 1 plus n minus 1 times the common difference. Then we need the following values, of course, to solve for s sub 25. Okay, first we need a sub 1, which is 18. And then we need also the common difference. So 38 minus 33, subtract it. We have 5. And of course, your n is the number of terms. We are solving for s sub 25, therefore n is 25. Then the next thing is we will substitute the values. S sub 25 equals n 20, so 25 over 2 quantity 2 times 18 plus n, which is 25, minus 1 times the common difference, which is 5. Then the next thing is we will follow the PEMDAS in solving for this. We will simplify everything inside the grouping symbols. Okay, so equals 25 over 2 is 12.5. You can already simplify that. Times 2 times 18 is 36. Plus 25 minus 1 is 24 times the common difference of 5. Then simplify 12.5 times 36 plus 24 times 5 is 120. Then simplify 12.5 and then 36 plus 120 is 156. Then multiply 156 times 12.5. The answer is 1,950. So S sub 25 is 1,950. That is the sum of the 25 terms of the sequence 18, 23, 28, 33, 38, and so on and so forth. So in this case, and in example 5 and example 6, you can now differentiate the uses of the two formulas. Okay? Next, let's have example 7. Find S sub 18 of the arithmetic sequence which general term is a sub n equals 15 plus 8n. So as you can see, we are looking for S sub 18. So before we can solve for S sub 18, of course, we can use the simple formula S sub n equals n over 2 times a sub 1 plus a sub n, or the first and last terms. So before we can solve the sum, of course, we have to consider the general formula in solving. So we have to solve first a sub 1 and a sub 18, which is the last term. So for a sub 1, just change n to 1. So 15 plus 8 times 1. So bring down 15, and 8 times 1 is 8. So 15 plus 8 is 23. Your first term is 23. Then let us solve for a sub 18. 15 plus 8 times 18. Then bring down 15. Okay, bring down 15. And then 8 times 18 is 144. So you just add 15 plus 144. So the answer is 159. So the 18th term is 159. 159 rather. So this is 9. And then we can now solve using the formula S sub 18 equals n, the number of terms we have 18, of course, since we're looking for S sub 18, over 2 times your a sub 1, which is 23, plus your a sub 18, which is 159. So 18 over 2 is 9, and then 23 plus 159 is 182. Then multiply 9 times 182 is 1,638. So this is now the sum of the 18 terms of the sequence. Given the general formula, A sub n equals 15 plus 8n. Okay? Next, let's talk about arithmetic mean. What do we mean by arithmetic mean? In our previous lesson about the introduction of sequences and series, we are able to identify the parts of a finite sequence. So in this case, when we say finite sequence, we have the presence of the extremes, which are the outer terms, and then all the middle terms are what we call means. So in this case, 15 and 78 are extremes, and 22 until 71 are what we call the means. Okay, so all of the terms in between the extremes are what we call means. Arithmetic mean. In the sequence x, m sub 1, m sub 2, m sub 3, and so on and so forth, m sub k, take note that we say that we have inserted k arithmetic means between x and y. So m sub 1, m sub 2, m sub 3, and m sub k are what we call arithmetic means. Okay? So we will start counting the mean like this case. This one is what we call m sub 1. Okay? Or the first mean. It's different when we say a sub 1. A sub 1 is 15. Alright? So how are we going to solve for arithmetic means? Example 8. What is the term between 14 and 28? Okay, what is the term between 14 and 28? So as you can see, we are only looking for the single mean between 14 and 28. Okay, so we have to count the terms 1, 2, 3. Teacher, how are we going to solve for the mean? First is you have to solve always for the common difference. Okay? In solving for the common difference, of course, we will use the same formula. A sub n equals a sub 1 plus n minus 1 times d. Okay, so in the formula, to solve for d, we need a sub 1, which is 14. And then we also need the last term, which is a sub 3. Why, teacher, a sub 3? Because as you can see, there are 3 terms. We have 2 extremes and 1 single mean that is unknown. So your a sub 3 is 28. And of course, your n is 3. Then substitute the values. A sub n, okay, is 28. Equals a sub 1 is 14 plus your n is 3 minus 1 times the common difference. So bring down 28 equals 14. 3 minus 1 is 2d. Then apply addition property of equality to isolate 2d. So 2d now will be equal to, bring down 28. Opposite of positive 14 is negative 14. So 2d equals 28 minus 14 is 14. And then divide both sides by 2 to isolate d. So therefore, d is equal to 14 divided by 2 or 7. This is now your common difference. Now, since you already have the common difference, you can already solve for the mean. So mean sub 1, you have to add a sub 1 plus the common difference. Your a sub 1 is 14 plus 7. So therefore, your mean is 21. So this will serve as your final answer. The term between 14 and 28 is 21. Now let's have the next example. Example 9. Insert 4 arithmetic means between 15 and 45. So in the previous example, we are only looking for single mean. But in this next example, we are looking for 4 means. So the extremes are 15 and 45. 15 and then first mean, second mean, third mean, fourth mean, and then the last term, which is 45. So how many terms do we have? 1, 2, 3, 4, 5, 6. We have 6 terms. Again, so just like what I'm saying before, you can solve for the means. Okay, you have to identify what is the common difference. Using the same formula, a sub n equals a sub 1 plus n minus 1 times d. So we need n, which is 6, and then our a sub 1, which is 15. A sub 6 is 45. And then, that's the time that we can solve. A sub n is 45, or the last term, equals a sub 1, which is 15, plus n, which is 6, minus 1. Since we have 6 terms, of course, n is 6. Times the common difference, which is unknown. Then 45 equals 15. 6 minus 1 is 5d. Then apply addition property of equality. 5d, bring down 45. Opposite of 15 is negative 15. So 45 minus 15 is 30 equals 5d. Then we need to divide both sides by 5 to solve for d. So therefore, d is equal to 30 divided by 5 is 6. That's the time that we can solve for the mean. So let's start first with m sub 1. In solving for m sub 1, you will add 15 plus the common difference, which is 6. This is now 21. Then to solve for m sub 2, okay, just add the first mean, which is 21 plus the common difference. So this is 27. To solve for m sub 3, okay, we have to add 27, which is the second mean, plus the common difference. This is now 33. And then m sub 4, you have to add 33, which is the third mean, plus the common difference. So this is now 39. So the means are 21, 27, 33, 39. So you can also list them down: 21, 27, 33, and 39. Okay, so how did we do that? First is you have to solve for the common difference before you can actually solve for the means. Okay, so that's it. Now, let's consider the following problems applying the concepts about arithmetic sequences and series. So answer the following problems. Now, letter A stone is dropped from the airplane. Let's say this is a perfect airplane. Even though it looks like fish, let's say that's an airplane. Neglecting other outside forces, the stone fell 16 feet during the first hour. So therefore, let's say during the first second rather. So during the first second, it fell 16 feet. During the second second, it fell 48 feet. And then during the third second, it fell 80 feet. What we are looking for is how far does the stone fall during the first minute. Okay, so let's say during the first minute, what is the distance? Okay, so we are looking for the number of feet. Okay, so first is let's write the sequence. 16 for the first second, 48 for the second second, and then 80 for the third second, and so on. We will be using ellipsis here. Then we will use the formula a sub n equals a sub 1 plus n minus 1 times d. Of course, okay, before we can solve that, the question is how far does the stone fall during the first minute? Since in our given we have seconds, we have to convert 1 minute into seconds. So 1 minute into seconds is 60 seconds. Okay, so therefore we are looking for a sub 60. Okay, so a sub 60 is the unknown value. We need a sub 1, which is 16. The common difference, 80 minus 48 is 32. And the number of terms, of course, is 60 since we're looking for a sub 60. Then substitute the values. A sub 60 is equal to 16 plus n, which is 60, minus 1 times the common difference, which is 32. To get the common difference, you have to subtract. Okay, so next is 16. Then 60 minus 1 is 59 times 32. Then bring down 16 plus 59 times 32 is 1,888. Okay, then add 16. Okay, so now the final answer, or a sub 60, is 1,904 feet. Okay, guys, please don't forget to put the unit of measurement, okay, in your final answer. So it's 1,904 feet during the first minute. So this will serve now as your final answer. Okay, what did we do? We just look for the nth term, which is a sub 60, or 1 minute. Next, a conference hall has 20 rows of seats. The first row contains 20 seats, the second row contains 22 seats, the third row contains 24 seats, and so on. How many seats are there in the last row? How many seats are there in the conference hall? In this specific example, guys, we are looking for, we need to answer two questions. how many seats are there in the last row, and how many seats are there in the conference hall. Okay, so since there are 20 rows, in the first question we have to answer if what is a sub 20. Because as you can see, the question is how many seats are there in the last row. And then in the second question is how many seats are there in the conference hall. So therefore, we need to add all the chairs in the conference hall. So we need to solve for S sub 20. So in this case, we are hitting two birds in one stone. Okay, because we need to solve for the nth term and also for the sum of the seats. Okay, so to solve for a sub 20, of course, we need to use the formula a sub n equals a sub 1 plus n minus 1 times d. Okay, and then the next thing that we're going to do here is to identify the values that we need to solve for a sub 20, like your a sub 1. Okay, so by the way, this is our sequence 20, 22, then 24, and so on. Your a sub 1, of course, is 20. Your common difference, 24 minus 22, is 2. And your n, of course, is 20 since we're looking for a sub 20. Now, substitute the values. A sub 20 equals a sub 1, which is 20, plus n, which is 20 minus 1, times the common difference, which is 2. Then simplify 20 plus 19 times 2. Then 20 plus 19 times 2 is 38. Then 20 plus 38 is 58. So this is now your a sub 20. So therefore, we can say that there are 58 seats. This is now the unit of measurement. 28 seats in the last row. So this is now your answer in the first question. How about S sub 20? So S sub 20, okay, just use the simple formula since we already have the first term, which is 20, and the last term, which is 58. Okay? The formula that we're going to use is S sub n equals n over 2 times a sub 1 plus a sub n, which is the last term. So S sub 20 now will be the number of terms 20 over 2 times your first term, which is 20, plus the last term, which is 58. So 20 divided by 2 is 10. Then 20 plus 58 is 78. Okay, so 10 times 78 is 780. So therefore, how many seats are there? There are 780 seats in the auditorium or in the conference hall. This will serve now as your final answer. See, we are able to use the two formulas for the nth term and then for the sum in solving or answering the two questions. If how many seats are there in the last row and how many seats are there in the conference hall. So that's it for arithmetic sequences and series. So I do hope that you learned a lot. And then if in case you have some questions and clarifications, you can comment down, or for my students, you can message me directly so that I can actually help you with your concerns and questions regarding this lesson. Now, for my students, please don't forget to do this activity on your activity sheets, and then we will be checking it next meeting. Okay? So I thank you so much for staying with me today for our new math lesson. So I do hope that you learned a lot. Again, so please don't forget to hit the subscribe button and the notification bell. Again, thank you so much. This is Teacher Dong. Have a great day.